Okay. Hi everyone, I'm Josep Bonsoms. I'm a PhD student from the University of Barcelona. I'm working in the Antal Research Group, and this presentation is about the extreme melting events in Greenland Ice Sheet. I will show you the recent spatiotemporal trends and the physical drivers. So this is part of the Neolast Hallucinations in Western Greenland project within the Antal Group. So first of all, I will explain what is an extreme melting episode. Then I will show you the trends of extreme melting episodes and the trends of melting in Greenland Ice Sheet. I will explain why there's an increase of extreme melting in Greenland, and I will show you which are the implications of Greenland ice melting. So extreme melting events are a kind of heat wave that are happening over the Greenland Ice Sheet, and they are characterized by have a very intense daily meltwater with values very high. And in this case, in this presentation, is about the data from the Model Atmosphere Regional, which has been validated previously in Greenland with observations and remote sensing data. Here you can see a definition of a heat wave, and you can see that in the blacker points, we have a very intense daily accumulated meltwater, which is over the threshold that we define it for a heat wave event. So here you can see the spatiotemporal evolution of extreme melting events and melting over the Greenland Ice Sheet. As you can see, there's a positive evolution for all of the sectors of Greenland Ice Sheet. And the higher trends are detected in the northwest and northeast sectors of Greenland. So the increase of extreme melting events is related with more energy available for melting and with more quantity of extreme melting during summer. This is also related with an increase of the frequency of extreme melting events. As you can see, there's an increase of extreme melting, mainly in the ablation area and in the ablation area near to the accumulation area, because this zone is near to the isothermal conditions and it's at a low elevation rate. So if we want to know why there's an increase of extreme melting events, we need to do a synoptic classification. Synoptic classification is a classification of circulation weather types during summer. And we can classify the circulation weather types into anticyclonic weather types or cyclonic weather types. Anticyclonic weather types are related with high pressure systems, and cyclonic weather types are related with low pressure systems. Normally, low pressure systems are related with precipitation, and anticyclonic weather events are related with melting. Here you can see the result of the synoptic classification, and each day is classified into 20 circulation weather types. If we look at the contribution of extreme melting events grouped by circulation weather types, we can find that 7 circulation weather types, which are related with anticyclonic weather conditions, are driving the extreme melting episodes in Greenland Ice Sheet. Here you can see all the circulation weather types, and you can see the average of extreme melting for each circulation weather type. Here you can find the same information, but in a bar plot. In the horizontal axis, you can see the circulation weather types, and in the vertical axis, you can see the contribution of each synoptic weather. So if we look at the evolution of cyclonic and anticyclonic weather types, we can find that there's an increase of anticyclonic weather types, especially during since the 90s to the present, and there's a decrease also of cyclonic weather types. And maybe you might ask why there's an increase of anticyclonic weather events and an increase of floating episodes over Greenland during summer. If we want to know why this is happening, we need to look at the snow cover conditions during summer and spring in the northern hemisphere. And we can link the decrease of snow cover in the northern hemisphere with the increase of floating events in Greenland. So the decrease of snow cover in Canadian Arctic and in the northern sides of America during spring and summer is changing the jet stream conditions over Greenland. So in the end, the temperature is increasing in Greenland Ice Sheet, and this is because there's a change in the fluxes of energy between the atmosphere and the surface. There's an increase of short-wave radiation and also an increase of long-wave radiation, and at the same time, an increase of sublimation in the ablation areas of the Greenland Ice Sheet. So the increase of long-wave radiation is linked with an increase of cloud cover, because a warmer atmosphere and an increase of evaporation is leading to more cloud cover conditions over Greenland ice sheet, which is linked with the increase of long-wave radiation. There's also an important change in the surface of the Greenland ice sheet, which is the albedo. The albedo of Greenland is decreasing, and this decreased albedo is contributing to the increase of melting. So in the end, we have a lower albedo, which means that all the energy coming from the sun is absorbed by the surface. Here I want to show you the impacts of extreme melting events in Greenland ice sheet, but also outside of Greenland ice sheet. Extreme melting episodes and melting episodes in Greenland are leading to an increase of the snow lines. So the snow line is moving towards higher elevations, and this is also decreasing the albedo, and it's amplifying warming, and it's changing the ice structure of the ice sheet. And an extreme melting event, what can lead is an increase of melt layers, crevices, moorings, and superglacial lakes over Greenland. And this will accelerate the melting in the same summer where we have an extreme melting episode, but also this will increase the melting in the subsequent years. So outside of Greenland ice sheet, if we have a melting event or a heat wave episode, what will happen is that permafrost will thaw, and this will increase the greenhouse gases emissions, and will have important implications in the ecosystem. Outside of Greenland, the increase of melting can also lead to changes in the ocean circulation and will change the climate patterns near the Greenland ice sheet. But the most important implication is sea level rise. Melting of Greenland ice sheet is leading to an increase of sea level rise, and on average, the melting of Greenland is contributing to around 300 gigatons per year. So I'm finishing the presentation. Here you can find all of the information that I've been showing, and it's available in this paper. So thank you very much for your attention, and feel free to ask me whatever. Questions?